Now, what's crucial when we start this is this whole thing with your classes. Your classes are crucial. Everybody's got the same thing as a result. Nobody has to stop and say, oh, I think I'll make mine 20 to 25, 26 to 30. Nope, we all end up with the same thing, and they all begin with the very first entry. It always starts with the first entry. What happens if you don't round up is this last part. If the last piece of data I had fell at the end, you would miss it. This last piece of data I think was like 82 or 81. It felt close enough in here. But if my last piece of data was 88 and I didn't round up, I would miss it. So you have to make sure you always round up when you do your things. No matter what the rounding rules are, make sure you round up. Okay? Everybody's good with that part? All right, we're going to work on the rest of this. We go through a lot of graphs in this section, and even though they look familiar, some of them we do process a little bit differently than you have in the past. It kind of makes it more readable. You're being a business world when you do statistics. You're presenting to people that aren't taking math classes, that didn't look at the intervals, didn't do the timelines. You're presenting to upper level people when you give your presentation. So you want to make sure that you're presenting the right way. All right. So the second part of this we're going to look at is your relative frequency part. Your relative frequency is just a proportion. It's a part over whole. That's all this is. It takes the class frequency, whatever frequency that was for that class, over the total frequency. The class frequency over the total frequency. In other words, they say how many was in your sample size. You surveyed 30, your total frequency would be 30. It's always a part over whole. And we divide it out. And rule of thumb is when you round to 3 decimal places. Round to 3 decimal places. Some of the books sometimes rounds to 2. We can round to 2. But it's a good one to round to 3. Mostly because if you round to 2 decimal places, and then you take your percent, your decimal, and you turn it into a percent, you move this 2, it's 59%. You kind of lost another decimal here. If we did this, 0.595, and we moved your decimal place, it wasn't exactly 59%. So it just gives us just a little bit more exactness. That's what that third decimal place does. We round in pre-calc to the third decimal place. We round in statistics to the third. Mostly in probabilities and anytime you have a percent. Because otherwise you kind of cut it off without a decimal place. And you want to kind of keep that decimal place. So we're going to take a look at part over whole. And we're going to take a look at your relative frequency. So if you take a look at page 43, they built their relative frequency. Okay. We found your midpoints yesterday. And we said you could add your class width all the way down. And this class width was 40. So we could add this all the way down. Okay? It saves you a little time, and I think you saw it yesterday, of having to find each one. Okay, Your relative frequency says, add up your total frequencies. This was the original one that we did in example 1. Example 1 told us that we had 30 navigational systems, 30 GPS systems. And we charted the frequencies, we found the class scripts, they wanted us to make 7 classes. We found the beginning, we did our tallies, and we found this together. These add up to 30. Okay? So now what we're going to do is we're going to do part over whole. 6 over 30. 9 over 30. All the way down. If I added up this column, what do you think it would add up to?
1.
1. Good. We have to have all our frequencies, and now, right now, they just sit as fractions. We're going to take those fractions and just divide it out. So they divided it all out for you guys, and they got 0.2. It's in your book. 0.3, 0.2. See, the 6's are the same. They got 0.13. I go 3 decimal. They probably ended. They probably terminated. 0.07. These will always add up to 1. These are your relative frequency. Part over whole. We do a relative frequency graph in here. You do your histogram. Your histogram had all the bars. However this works out. And you put your total frequency over here. So you had 1, 2, 3, all the way up. Your relative frequency is going to look the exact same. Only instead of a frequency, it's just going to have your relative frequency there. So your graphs are going to look identical. You're presenting the same information in a different format. What even happens as you present these, you probably want to take your relative frequency and sometimes put it in a percent. A lot of people deal with percents better. They don't see the decimal. If I say 0.3, they don't see that as 30%. You know, you have to remember who your audience is when you present your information. In class, yeah, we know what we're doing in here, but like when you go to present this, sometimes they say, just give me bottom line, percent. What's my increase? What's my decrease? Percentage, bottom line. So sometimes you're going to present that with a percent out there, and you can take your decimals and convert them real easily. So this is your relative frequency.
Does it matter if we always do percents?
Well, I want the relative frequency. I want the decimal. But I'm saying sometimes, like in the business world, you might have to put a percent out there. You know, depending on who your audience is. You know, sometimes they like circle graphs better because they like the percentages. Yeah. You know, it depends on how detailed your audience is. Now, your cumulative frequency, we did this back in probably 8th grade. It's you keep totaling. You keep a running total of your frequencies. So we start with your smallest one. And we add. We keep a running total. You add 9. You add 6. You add 4. See where it's coming from? It's just a running total. You add 2. You add 1. And then you add 2. This number has to be exactly what this number is. If it's not, something went wrong. It accumulates to the highest one. Now, this is the biggest one. You're going to see a difference in the graph because normally we did your bar graphs so that they constantly went up. In statistics, we don't do a bar graph for this. We do a line graph, and we show the line going all the way up. There's just a little bit of a different look to it. So we do a couple of little different things when we hit the graphic organizer parts. Today, I really want to focus on making sure you get all the pieces to do this. So everybody okay with the cumulative frequency? Okay, so now what you're going to do is you're going to take the chart that you had and you're going to fill in a relative frequency and a cumulative frequency column. Anybody remember what the frequency was for this? How many? 50. Good. No, not the class boundaries yet. We're going to work on class boundaries next. So we know that your frequency adds up to 50. This should make your relative frequency very smooth. So your cumulative totals are just keep bringing the totals with you. Carry it with you. Start at your smallest one and think about putting them in a basket. That's the easiest way to remember it. Your relative frequency is always part over whole. Since we're based on 50, this is 2 over 50. Divide it out. Put it in your calculator. 0.04. This is 5 over 50. 0.10. This is 12 over 50. 0.24. 18 over 50. 0.36. 11. You also do this same routine to get your circle graph information. Whenever you do your circle graph and you're using percentages, part over whole. And 0.1 and another 0.1. If I added up this whole column, what should it equal? 1. Because they're all my parts. Now, the last segment we're going to hit is your class boundary. Remember we said there was a little bit of a problem. If I did 65 to 104, and then I started 105 to 144, here's my bar, however big the bar is, I have a gap right here. I have a gap in my data. When we use the midpoint, it takes care of that gap. But sometimes we have to use the upper class boundary. We have to go from the beginning to that point, especially on your cumulative, because your cumulative says you're accumulating from 65 all the way up. So we have to find a class boundary. It's kind of like if you put a little air conditioning unit in your window, right? Sometimes you have a gap, and they have these little extenders. It looks like a little fan that comes out like this, and it clicks into your window. You're just making it meet your window frame. So you're just making it so that this bar can come halfway here and meet. You just want it to meet. It's okay that you extend it a half because that value will never be there. 64 and a half will never be there. 104 and a half will never be there. Because these values were discrete. They were countable. They were the ages of people. No, these weren't the ages. This was the GPS prices. These were your GPS prices. Whichever one this was. So we accumulate these all the way through. And you keep track of your boundaries just so that when we do some of your x-axis, you might have to use an upper class boundary. So the rule is this. You take your class interval and you drop the low end 0.5. And then you raise the high end 0.5. This is basically what you're doing. Here's your 64. Here's your 104. You want to make this bar a little bit wider. So you drop the low end 0.5, 63.5. You raise the high end 104.5. Oops. Yeah, you drop this 0.5. Oh, I put 60.
You always just drop 0.5? Or
You always drop 0.5. There is no 63. Oh, wait, this, okay, sorry, this started at 65. Ah. Okay, this started at, I started this one there, that one's supposed to be 65. You start this at 65, so what is this going to be when I drop a 0.5? 64.5. This is the high end, 104. Raise that 0.5. Now, watch what happens. The next interval, when I drop 105.5, what does that become? 104.5. Look at this. There's no more gap anymore. See it right here? Yeah. It starts, but it's right up against that. There's no more gap in your intervals anymore. Before we had a little gap, and we shouldn't have. All the way through 8th grade, all the way through 9th grade, make the bars touch, and we shouldn't have.
We don't have gap in between what?
Because normally between when you do this, between 104 and the next one you start with, 105, you have a gap. But we make your bars touch. Yeah. But, and so what is half of 1? 0.5. So if each one moves 0.5 over, we met that. So that's exactly why we add the 0.5 and subtract the 0.5. So we take this guy, 144.5. Now, this one's going to start at 144.5, and it's going to go to 184.5. See it?
Wait, is that a dash or just?
That's this. It's a dash for this. It is your class interval. This original class interval was 145 to 184, so now we extended it to 144.5 to 184.5. This is now your new class. It's your new class interval. It's your new class interval.
So on the graph, when you're graphing it, you would put the class boundaries and make the classes?
Sometimes we'll use the midpoint. Sometimes we'll use the upper class boundary. So that it looks like this now. Say I'm doing a cumulative graph. That's one of the ones we use it for. So I've got to come down. I've got to start it here because I've got to have a starting point. Then I go like this. We're going to see this in a little bit. It's accumulating from here to here. Then it's accumulating from here to here. So it's going to each point as we do this. We have to use an upper class boundary on a cumulative graph. We could use it on your histogram, but it's easier to use the midpoint. One is dropping a 0.5. You off the lower end, you subtract 0.5.
Yeah, it would be 143.5.
No, on the high end, you add 0.5. You want to take this little bracket that goes like this. And you just want to put a little extension like this. You want to extend it. And Nick said there's one in between, so each one has to extend a half. So if this one's got to come out a half, it's got to drop to 64.5, right? If this one's got to come out a half, it's got to go to 104.5. It's kind of like your little air conditioning unit that you put in your window and you pull out the little sides. They got to meet the window. Otherwise you have gas.
We're extending the graph so that there's no gap between the bars, right?
Mm-hmm. No gap. We can't have a gap.
So
All those years you had to...
When we do our graph, we do class boundaries so that all the bars touch.
Yes. Or we can use midpoint. And that kind of takes care of your problem because you don't really see the end point of your boundary. You only see the midpoint of it. So that makes it look a little bit better. But sometimes like in a cumulative graph, they like to know where the end point is. Where did it come to? Where are you accumulating up to that point? So let's take a minute and let's do the class boundaries of this guy. So what would my first class boundary be?
25.5.
25.5 to what?
34.5.
34.5. Everybody okay with this? Can you see this over there? Okay, 25.5. Here I have a 26 to a 34. I need to drop this guy out here and over here. So doesn't that make sense? I drop it 0.5, I raise it 0.5. How about this one?
34.5.
To what? And look at this, there's no gap between your 34.5. It starts right there. Will I ever hit a 34.5? No, because my data's discrete. My ages were whole numbers. So it'll never affect the count for that interval. All it will do is make my graph flow a little bit better. So how about the next one? Put this on your chart. Good. 43.5 to what?
54.5.
52.5? Okay, next one?
52.5.
52.5. Make sure it's on your paper.
61.5.
Good.
61.5.
61.5.
13.5. 79.5. 79.5. 88.5.
To 88.5. Okay? Everybody get the intervals? TJ, did you write your intervals down? Good. Okay. Any questions on your intervals? We have a few more minutes. All right. Now, take a look at your homework last night. Take a look at your homework for me. All right, I want you to make the class boundaries for the first 2 entries in your tables. Make me class boundaries.
Okay, now?
Yep, that would be a good time. Class boundaries, you only need to do the first 2 entries. No, write them in your homework. Yes. You got 25. Okay, because your class width was 8. Your class width is right here, right? Now, what's the next one down? If you add 8 to this, what do you get? 25. So therefore, you have 20. You have 20.
No, I wrote.
Oh, you wrote. Okay. Okay. So your class width comes. Just do one more.
No.
25. When you do this, it's technically like if I say 5, 7, looks like 2, 5, 6, 7. That's why we do the class boundaries down. Yeah, that's what I'm saying. Yeah, that's all I want. That's all I want you to go down with these things all the way down. Okay, so what do we get for the first one?
8.5 and 16.
8.5 to 16.5. The next one?
16.5.
Good. How about number 12? 11.5. Good. Aaron, how about this one? So do it for me now. Guys, 16.5, 31.5. Good. Here, Julia, how about this one? Okay, very good. Everybody getting the pattern here?